Hello everyone, I'm Yazan Ibrahim, or as some of you might know me, Yazan Abu Ghosh. Today we're going to dive into a fascinating and essential topic. From Chapter 4, Part A, Information Systems Operations 4.11, Database Management. If you are a seasoned auditor or just curious to understand how information systems into business environments, you've come to the right place. Let's begin. The foundations of database management. The digital world thrives on data. From social media posts to medical records to the purchases we make online, data surrounds us, constantly shaping the digital services we rely on. But have you ever wondered, how do organizations manage these colossal troves of information? Enter the Database Management System, or DBMS, a silent hero in the story of data management. Let's take a journey through the intricate and fascinating world of DBMS, exploring its structure, architecture, and how it transforms raw data into meaningful insights. What is a DBMS? A database management system is specialized software designed to organize, control, and facilitate the use of data for various applications. Think of it as the brain behind every robust database, working tirelessly to achieve three core functions: reduce redundancy, make data access faster, and safeguard sensitive information. Imagine this. At the base level, a DBMS organizes data into fields such as social security numbers or product IDs, basic building blocks of information. But it doesn't stop there. Above these fields are layers, meticulously arranged levels built to match the architecture of the database, ensuring every byte of data is meaningful and accessible. This system might even include a data dictionary, like an internal encyclopedia, detailing all the fields, their characteristics, and use cases. Now, there are two kinds of data dictionaries: active data dictionaries, which actively guide applications, validating inputs or formatting outputs, and passive dictionaries, which are essentially static references that don't directly assist with workflows. But regardless of the dictionary type, a DBMS offers unparalleled control. It governs who gets access and at what level, be it individual users, specific transactions, or even down to single data fields. This makes it flexible, precise, and most importantly, secure. Advantages of a DBMS, why you want one. So what makes a DBMS indispensable to modern organizations? Well, there's a long list of advantages, but here are the highlights. First, data independence. Application systems can rely on stable data structures, while the backend evolves independently to meet new requirements. A DBMS also shines in transaction processing, where efficiency is key. Think of every transaction, whether a bank transfer or a logged event in a factory, as a piece of the larger picture. A DBMS ensures these pieces fit together seamlessly. It minimizes redundancy, maintains consistency, and reduces overall maintenance costs through data sharing. Essentially, it ensures that everyone in an organization works from a single source of truth. On top of that, DBMS systems are champions of data security and integrity. They offer safeguards against unauthorized access and ensure every data element remains accurate, complete, and most importantly, trustworthy. And let's not forget a feature any data scientist or analyst will love: query languages. Users, even those without technical backgrounds, can retrieve data easily via friendly user-designed tools, introducing DBMS architecture, the framework behind the magic. Now, let's pull back the curtain and look at how a DBMS operates behind the scenes. The DBMS runs on metadata, which captures information about data, things like field definitions, relationships, and queries. This metadata is organized into three layers, or schemas, known as 1. Conceptual schema, describing the logical structure of data. 2. External schema, tailored for individual users or programs. 3. Internal schema, detailing data storage and physical organization. You can think of these like architectural blueprints. Unless they align perfectly, the entire structure, your database, risks crumbling at critical moments. Within each layer lies the Data Definition Language, DDL, a set of tools that lets database administrators model and map the connections between these schemas. This ensures that whether you're dealing with metadata for external use or storage level specifics, it all flows together harmoniously. Data dictionaries, the brain of DBMs. At the heart of this architecture is the Data Dictionary Directory System, DDDS. Picture it as a central index tracking every data item, its location, and its use. But it doesn't just store descriptions. The DDDS includes powerful tools that let administrators design mappings between different schemas, validate data definitions to ensure integrity, and block unauthorized access. It even offers search features so administrators can interrogate and better understand how data flows within the organization. The DDDS's greatest strength: universality. It can serve multiple DBMS systems, making transitions from one platform to another smoother. Unsurprisingly, this feature enhances documentation, standardizes programming, and simplifies database management across the board. Database structures, building blocks of a DBMS. Now let's explore the heart of database management, database structures. There are three major types, each with its strengths and limitations. Hierarchical databases. Think of a family tree or a Microsoft Windows registry. This structure connects parent and child data elements in a one-to-many relationship. While excellent for tightly structured environments like geographic databases, it's rigid and requires data duplication to link multiple parents. Network databases. In contrast, this model builds on flexibility. Here, data relationships are multi-owner, allowing for complex web-like structures. However, it's notorious for its steep learning curve and complexity in troubleshooting. Relational databases. This is the star of modern database management. Based on set theory, it organizes data in dynamic, highly flexible tables called relations, where rows or tuples and columns, attributes or domains, come together seamlessly. Relational models make joining multiple tables, implementing access controls, and adapting to evolving business needs easier. Systems like Oracle, IBM DB2, and Microsoft SQL Server follow this model. Emerging models, NoSQL to UDBMs. Yet the world has evolved, and so have databases. Two cutting-edge models deserve mention. One, the Object-Oriented Database Management System, OODBMs, ideal for handling multimedia, diagrams, and other complex datasets. This model treats stored elements as objects with embedded attributes and executable code, a boon for engineering, design, and spatial applications. 2. NoSQL databases. The revolution brought by big data demanded solutions like NoSQL. These systems thrive on unstructured data, audio, video, tweets, logs, etc., and embrace horizontal scaling and dynamic schemas. Common tools like MongoDB and Cassandra prove crucial in today's vast digital landscape. Database controls, protecting what matters. No discussion of databases is complete without delving into controls, measures to ensure integrity, availability, and accuracy. A good DBMS enforces standards, backs up data meticulously, and controls access to specific fields, tables, or even individual users. Transactional locks ensure multiple users can't override each other's changes at the same time, while built-in checkpoints minimize recovery efforts after system failures. Auditing and reviews, ensuring excellence. Finally, the key to long-term success lies in reviews. By auditing database design, access controls, and disaster recovery plans, organizations ensure their databases remain optimized for changing needs. This includes everything from securing sensitive data with encryption to analyzing access reports for potential breaches. The DBMS legacy. In conclusion, the database management system is more than just software. It's the backbone of the information age. Whether it's safeguarding sensitive data, enabling seamless user experiences, or managing the unmanageable chaos of big data, the DBMS is the unsung hero of modern organizations. A well-implemented DBMS is not just a tool, it's a competitive advantage, driving innovation, and unlocks a world of possibility. So, as we log off today, remember, every piece of data you interact with has a home. And somewhere behind the scenes, a DBMS is working overtime to keep your world spinning. Thank you for watching, and as always, continue learning. Stay curious, and we'll see you next video.